Hi, my name is Ethan Seprin, and welcome to Shark Tank. I believe I have a product here that can change your life. This here is a motion sensor nightlight. Every night, some people wake up, have to go to the bathroom, but they don't want to because they're afraid you might stub your toe, you might not be able to find the light switch, and they're afraid that they're not going to be able to fall back asleep with all the bright lights on. So, I built this contraption here. Detects your motion, works best at night, and lights up the toilet. So this is best done in the dark, but as you can see here, once I turn the lights off, I'll flip this switch and show you how it works. I'm gonna flip it on now. As you can see, when I moved, the light turned on. It's amazing. Or when I'm moving. So, no, not everybody likes to pee with the same colors. There's blue, red, green, and some people need a little extra brightness. And with the click of a button, it can go right back down. Perfect timing. Now that we have the lights back on, I can show you the inside of the product. Flips open. This is a 3D printed body that I had made especially. This is the battery pack. Takes 4 AA's. Get that down though. Here is our Arduino board. Power goes in there. As all our wiring. Only for the circuit, only one resistor is needed, so I put that directly in there. As you can see there, everything is taped together so nothing falls apart. And then, yeah, very nice not to have a breadboard in there. That saves a lot of space, but as you can see on the inside, we have a lot of open space in there that we can cut down on. And for the future, and with a smaller board, a smaller power supply, I believe we can get a smaller button. Should also show battery pack is held in using Velcro so that it also keeps the door shut as well. And it keeps the board in place. But for the future and with investments, this build took about $40 for all the sensors, lights, and the Arduino boards, and the build, and the 3D printer. If we can find a way to cheaply produce the body and make everything smaller, costs will go down. I don't think we need an 8x8 light. We might even just need 2 strips or make more versatile, mobile, and such. And yeah, this is the motion sensor nightlight. Thank you. Hello, and welcome to the second part of the presentation. Following the venture capital part, I just wanted to go over my code, SolidWorks, and the circuit a little bit. So first thing we have here is the circuit and some of the sensors as well. So we have the button that you can see there. We have the motion sensor, which is up there. And then we have the 8x8 LED strip, which is not a sensor, but it is part of the circuit. And so you can see faintly right here is a resistor. I believe it is a 130 ohm resistor going into the LED strip. And the nice thing about this circuit is that was the only addition needed to make it work. So no need for a breadboard or anything. I just put the resistor right in, which I guess I don't know how suitable it truly is, but I saw a hack for it online and it saved a bunch of space later on. And then we have the power supply here, the 4 AA batteries, which I showed earlier, and it's just wires in and out. No need for any MOSFETs, transistors, or anything. I did play with the idea of like a potentiometer for the brightness, which maybe in the future that would be better than the button. but I thought the button was a good add-in because my original idea was just the motion sensor turning on the light, and I wanted to make it a little bit harder, I guess, and add on to it and be able to change the color and customize the light as well. So, that being said, the code really neat. I really utilize the H libraries, just searching what each part kind of what is recommended for them. And the two I found were a button H library, just got it right off of Arduino, I believe. And then the fast LED NeoPixel, this was to control the 8x8. And those two were lifesavers, as you can see here in line 1. I'm activating the button, just defining what pins each button goes into, and then just defining initial values here. C is just which stage of the color, or which brightness level it is at. And then later on, I'll show you the functions. The main ones were LED on and LED off, and I had 3 different button functions as well. And so for the NeoPixel library, you had to define the data pin, which is where data was coming from. Defined the initial brightness as 5, and you have to define the brightness here. For the variable brightness, to make it so that the brightness could be variable later on, I made that a variable inside there as well. The number of LEDs there, 8 by 8 by 8 means 8 times 8. And the cool thing about this is that we could add as many lights as we wanted to this, and all we would have to do is just adjust that number, and the rest of the code would take care of itself. So I played with the idea of a minute on, but for demo purposes, that would seem a little silly. Had reset time built in, and that is just a delay where nothing happens. Allows the code to kind of catch up with itself and operate better. See motion pin, that is just where the data comes from the motion sensor into the Arduino. And initial state low, that means nothing is detected. Initial value 0. And then start time actually didn't really, nope, start time was very necessary later on. Later on, you'll see define it as when the light turns on, and then the elapsed time, that is just defined as 0 as well. And on time, we have set to 15,000, which is just 15 seconds, and total time actually was not necessary. Then we have other setup here, making sure everything that needs to be defined is defined, making sure that the motion pin is defined as an input. Just put the serial monitor at 9600, it seemed to do plenty, and then it sets the strip brightness is set, all the buttons are initialized, and then we have our loop. So every time running through the loop, the value of the motion pin is determined. If the value is high, which means motion is detected and the state is considered low, state is put to high, and then if this is plugged in to the serial monitor, it'll come up as serial motion detected space. LED on obviously turns on all the LEDs. I can show you how I did that later. And then LED off is where the magic happens with the timer is set, or sorry, start time is determined, the elapsed time is running, and is running against the on time. And otherwise, yeah, it just goes through that. There's a delay in there, or built into there also, so that lights turn off after the elapsed time, but buttons are able to be pressed and make changes to the light. And then if motion is not detected, LED is off, or it stays off. Basically, all lights values are zeros. If the state is equal to high, the state is equal to low. And for the LED on, it's very, very simple. The strip, set picks color, strip color, strip show, those are all terms from the library. And when the LED is on, again, start time equal to the current time. And for I equals 0 through the number till one less the number of LEDs, because it counts the first light as 0, and then I plus plus, that just, it goes through all of them. And it turns all the lights on nearly simultaneously, and it sets them to the basic color, which, if they're all 255, that is white. And strip show shows them. And LED off, this is where a big chunk of code happens. And the elapsed time, or E time, is current time minus the start time. If button 1 is pressed, button 1 function, which you can see over here, C equals 1, brightness equals 10. Button 1 is when you press into the thing, so it is what brings the brightness back down to 10, or it's like a reset. Button 2, that increases the brightness. I can show you button 2 over here. C is equal to 2, the brightness is 20, it's 3, 40, 60, 80, 100, 150. So that's every time the button is hit, it goes up in brightness until it reaches this max, and it just keeps running itself in a loop otherwise. And then once button 1 is hit, it goes back down to 1, and you can repeat that. And button 3 is what changes the color. I'll show you that on the next slide. And then if the on time is less than the elapsed time, that means the elapsed time has gone on for longer than what we want the on time to be. Everything is set to 0 for the same thing as above, but colors are changed to 0. And then we have a little second delay before it can turn back on and set the state to low. Then we have button 3, which is the color button, and if color is equal to 1, we have white, or sorry, if color is equal to 0, we have white. If color is equal to 1, we get blue. If color is equal to 2, we get red. If color is equal to 3, we get green. And if color is then added, and it goes to 4, then color is equal to 0, and we go back to white. And these are just initializing. It was important at the end of all of this to initialize and to get the immediate change. I believe that is it. And then this is the 3D rendering of my body. Here we have the motion sensor hole. This is the hole for the wires to go through for the light, and then over here you can't see it, but is the hole for the button. This little guy here is just to hold the, or help hold the Arduino board up. And then we also have a hole to access the switch. The door was a little difficult to design, and just making sure that there's enough space to rotate without anything running into each other, and also having to adjust for tolerances in the 3D print as well. Coming up with this, I basically just put everything in a way that I felt like the wires weren't totally running into each other and causing issues, and it seemed like the most the most economic way to put everything in, making the best use of the space. But even still, power cords from battery pack going in added an extra 1.5 inches to the Arduino, so in the future I would try and slim everything down with smaller components.